Welcome to the class of Advanced Statistics and Econometrics. In today's lecture, we are going to discuss linear regression model. The linear regression model is the general form of linear regression model, LPM model, or linear probability model is yi is equal to b1 plus b2 times x2i plus b3 times x3i plus b4 times x4i till bk times xki plus ui, where ui is the disturbance term. b1, b2, b3 till bk are coefficients, unknown parameters which we need to estimate. X is x2, x3 till xk are independent variable and y is dependent variable, or it can be written in the short form as yi is equal to b, which is a vector, times x, which is another vector, plus ui. So when you write this in matrix form, you will see that with a number of observation, x's are basically having a dimension of k by n. y y is the regression and x is a vector of regressors. This is what I just explained. The regression is also called dependent variable and regressors are called independent variable. And u is an error term. So population model or true model, here we have this same equation. It is known as the population or true model. It consists of two components. One is deterministic component bx, the conditional mean of y or expected value of y given x, and non-systematic or random component ui. So we need to maximize this deterministic component and minimize the random component by selecting a value of the parameters beta. So regression coefficients, b1 is the intercept, b2 to bk are the slope coefficient. Collectively, they are the regression coefficients or regression parameters. Each slope coefficient measures the partial rate of change in the mean value of y for a unit change in the value of a regressor, ceteris paribus. So ceteris paribus is other things remaining same or other things remaining constant, they are not changing. So if each slope coefficient you need to interpret, you can say that this is the partial change in the mean value of y for a unit change in the value of regressor. So the sample counterpart is yi is equal to b1 plus small b2 x2i plus small b3 x3i till bk xki plus ei. Remember, when we write this as the sample counterpart, b1, b2, b3 are basically estimate for beta 1, beta 2, beta 3, which are unknown but constant. And in the sample, these b1, b2, b3, they are known but they are variable. They changes from one sample to another sample. Or it is written as yi is equal to b times x plus ei, where e is the residual. So here you know the difference between error and residual. Error is in the true model population and residual is for sample. So the deterministic component is written as y hat I plus b1 is equal to b1 plus b2 times x2i plus b3 times x3i plus b4 times x4i till bk times xki is equal to bx. So bx here is written in the form of matrix notation. So nature of the y variable, when we are talking about nature of the y variable, ratio scale, ratio of two variables, distance between two variables and ordering of variables are meaningful. So interval scale we have already discussed earlier, the difference between ratio and interval. So here distance and ordering between two variables meaningful but not ratio. Ordinal scale, ordering of two variables meaningful, not ratio or distance. Nominal scale, categorical or dummy variable, qualitative in nature. So, nature of the data, time series data is one type of data where a set of observations that a variable takes at different times, such as daily, say for example, stock prices, weekly, money supply, monthly, example is unemployment rate. So quarterly, example is GDP, annually, example is government budgets. Quinquennially, or every 5 years, the census of the manufacturers, or decennially, or every 10 years the census of the population. These are some of the examples of time series data where we have one set of variable or one variable which is taking different values at different time, and the time is fixed, that is duration is fixed, daily, weekly, monthly, quarterly. Second is cross-section data. Data on one or more variables collected at the same point in time. Examples are census of population conducted by Census Bureau every 10 years. Opinion polls conducted by various polling organization, and temperature at a given time in several places. So here you have measurement at a point of time, and this measurement is spread across different units. Nature of the data, panel, longitudinal or micro panel data, combines features of both cross section and time series data. So if you have features of both cross section and time series data, we call it as panel, longitudinal or micro panel data. So you can have same cross section unit are followed over time. So panel data represents a special type of pool data, simply time series, cross sectional, where the same cross sectional units are not necessarily followed over time. So if that is the case, we call it as a special type of panel data, that is of pool data, that is panel data. So method of ordinary least square. Method of ordinary least square does not minimizes the sum of square term but minimizes error sum of square. So it is not minimizing the sum of the error term, because if you are minimizing the sum of error term, then sum will be typically 0. Some will be positive, some will be negative. So overall, if you add, you will get 0. But if you square it, negative terms become positive, and you minimize the error sum of square, ESS. So UI square summation is equal to summation yi minus b1 minus b2 minus times x2i minus b3 times x3i minus bk times xki square. So the whole thing within the parenthesis is expression for ui, and you square it. So and then you sum it. You select b such that this term is minimized. So to obtain values of the regression coefficient, derivatives are taken with respect to the regression coefficient and set equal to 0. So if you take the derivative with respect to the regression coefficient and set it to 0 and solve, then you get the solution, and that is OLS. So classical linear regression model, assumptions of the classical linear regression model, or CLRM. Model is linear in parameter. Regressors are fixed or non-stochastic. Given x, the expected value of error term is 0, or expected value of ui given x is 0. Assumptions of this CLRM, homoscedastic or constant variance of ui, or variance of ui given x is sigma square. No autocorrelation, or covariance between ui uj given x is equal to 0. I is not equal to j. No multicollinearity, or no perfect linear relationship among x variables. Seventh is no specification bias. Gauss Markov theorem. On the basis of assumptions A1 to A7, the OLS method gives best linear unbiased estimators, that is blue. Estimators are linear function of the dependent variable y. The estimators are unbiased in repeated applications of the method. The estimator approach their true value. In the class of linear estimators, OLS estimators have minimum variance, that is they are efficient or the best estimators. Hypothesis testing. When you look at this hypothesis testing, you formulate a null and alternate hypothesis. Null here is b subscript k is 0 and alternative is b subscript k is not equal to 0. We calculate the following and use the t table to obtain the critical t value with n minus k degrees of freedom for a given level of significance, or alpha, equal to 10%, 5% or 1%. T is bk upon standard error of bk. If this value is greater than the critical t value, we can reject null hypothesis. So an alternative method is seeing whether 0 lies within the confidence interval. That is, we formulate a confidence interval around our obtained value, that is bk plus minus t alpha over 2 times standard error of bk, and this is equal to 1 minus alpha. If 0 lies in this interval, we cannot reject null hypothesis. If the p-value gives the exact level of significance or the lowest level of significance at which we can reject null hypothesis. R square, the coefficient of determination, is an overall measure of goodness of fit of the estimated regression line. R square gives the percentage of total variation in the dependent variable that is explained by the regressor. It is a value between 0 for no fit and 1 for perfect fit. Let explain sum of square ESS is summation y bar minus y hat minus y bar square. Y hat is the estimated value of y and y bar is the mean of y. Residual sum of square is summation of E square. Total sum of square is summation of y minus y bar square. Y bar is mean. Then R square is ESS over TSS. This is equal to 1 minus RSS over TSS. Hypothesis testing, F test. Testing the following hypothesis is equivalent to testing the hypothesis that all the slope coefficients are 0. Null hypothesis is R square is equal to 0. Alternate is R square is not equal to 0. Calculate the following and use the F table to obtain the critical F value with k minus 1 degree of freedom in the numerator and n minus k degrees of freedom in the denominator for a given level of significance. F is ESS upon degree of freedom upon RSS divided by degree of freedom. So F value is R square over k minus 1 upon 1 minus R square divided by n minus k. If this value is greater than the critical F value, then you can reject the null hypothesis that R square is equal to 0. And the reference for all this is a book Econometrics by example 2nd edition. Publisher is Palgrave Macmillan and author is Damodar Gujarati. Thanks.